In the beginning, there was nothing, not even space, time, or light. Only an infinite stillness that existed without form or meaning. Then, in a fraction of a second, everything changed. From that endless void, something unimaginable happened. The birth of the universe. An explosion, not like any explosion we know, but the sudden expansion of pure energy and potential. This was the Big Bang, the moment that created time itself. From nothing came everything. The universe began as an incomprehensible sea of heat and energy, a dense and chaotic storm, smaller than an atom, yet containing all that would ever exist. It was expanding faster than light, stretching the very fabric of space. Within less than a trillionth of a second, the infant cosmos inflated from a quantum speck to the size of a galaxy. This rapid inflation smoothed out the chaos, creating a structure that would later shape stars, planets, and galaxies. In those first moments, the universe was a furnace of unimaginable temperature, hotter than anything the human mind can grasp. Subatomic particles like quarks and gluons collided at near infinite speeds, constantly forming and annihilating one another. In this firestorm, the fundamental forces of nature, gravity, electromagnetism, and the nuclear forces were born. These invisible laws would forever govern the way everything behaves, from the smallest atom to the largest galaxy cluster. A few fractions of a second after the Big Bang, the universe had cooled just enough for quarks to combine and form protons and neutrons, the building blocks of matter. But this matter was fragile. For every billion particles of matter that formed, a billion particles of antimatter appeared as well. When they met, they destroyed each other, releasing bursts of pure energy. Yet somehow, a tiny imbalance remained, one extra particle of matter for every billion pairs that annihilated. That tiny imbalance, that 1 in a billion chance, is the reason why anything exists at all. Every galaxy, every planet, every living thing, all owe their existence to that fragile sliver of survival in the chaos. As the universe continued to expand, it cooled further. Within seconds, protons and neutrons began fusing into the first atomic nuclei, mostly hydrogen, some helium, and trace amounts of lithium. The universe was now a glowing plasma of light and particles. Photons, the particles of light, were constantly scattered by free electrons, bouncing endlessly in every direction. It was a storm of blinding radiation, opaque and chaotic. No structure could yet form. Time was young, mere minutes old, but already the blueprint of everything to come was written in the slight variations in density that rippled through this early sea of plasma. Tiny fluctuations, born from quantum randomness, were stretched across the universe during inflation. These small irregularities would become the seeds of galaxies billions of years later. For hundreds of thousands of years, the universe remained a swirling fog of charged particles. No light could escape its dense soup. But as it continued to expand, the temperature dropped below 3,000 degrees, Kelvin, cool enough for electrons to bind with nuclei, forming the first neutral atoms. For the first time, the universe became transparent. Photons could finally travel freely through space, and the first true light filled the cosmos. This ancient glow still exists today. We can see it as the cosmic microwave background, a faint radiation that surrounds us in every direction, the afterglow of creation itself. Each tiny variation in that light tells the story of the universe's earliest moments. It is the oldest light we can ever see, a silent echo of the birth of everything. But though the universe was now filled with light, it was also dark. There were no stars, no galaxies, only vast clouds of hydrogen and helium drifting in the emptiness. This was the cosmic dark age, a time of silence and slow transformation. Gravity, the great sculptor of the cosmos, began its patient work. Over millions of years, gravity pulled the slightly denser regions of gas together. The more they pulled, the more matter gathered. Knots formed within the vast clouds, and their pressure and temperature began to rise. Deep within these collapsing pockets of hydrogen, something extraordinary happened. The first stars were born. When the first star ignited, it ended the age of darkness. The universe lit up with starlight for the very first time. Nuclear fusion roared to life inside those early giants, turning hydrogen into helium and releasing enormous amounts of energy. These first stars, known as population IN stars, were far larger and hotter than any that exist today. They lived fast and died young, some lasting only a few million years. When they exploded as supernovae, they released the first heavy elements into the universe: carbon, oxygen, iron, and more. These were the elements that would one day form planets, oceans, and life itself. From their death, creation continued. As more stars formed, they gathered into clusters and galaxies, creating the first cosmic structures. But in this early time, galaxies were small, chaotic, and violent, constantly colliding and merging. Out of this chaos, the great cosmic web began to form a vast structure of filaments and voids, stretching across unimaginable distances. Dark matter, the invisible scaffolding of the universe, guided this formation, pulling regular matter into its gravitational wells. In the heart of some of these early galaxies, black holes began to form. Born from the collapse of massive stars, they grew by devouring surrounding gas and merging with others. In time, they became supermassive, millions or even billions of times the mass of the Sun. Their intense gravity and radiation shaped their galaxies, blowing away gas and controlling star formation. The universe, once a chaotic ocean of plasma, had now matured into a structured cosmos filled with galaxies, stars, and worlds yet unborn. Billions of years had passed since that first instant of expansion, but the echo of the Big Bang still resonated through space. As we look deeper into the cosmos, we are looking back in time. Every photon we capture from distant galaxies has traveled billions of years to reach us, carrying the story of creation. We see galaxies as they were when the universe was young, stars forming in clouds of dust, and the faint glow of the first light. Through them, we can trace our origins to that singular moment when everything began. Scientists still question what caused the Big Bang. Was it the result of a collapsing universe from a previous cycle? Was it a quantum fluctuation in an eternal multiverse? Or was it a spontaneous event from absolute nothingness? No one knows. Perhaps the question of before has no meaning since time itself began at that moment. The Big Bang wasn't an explosion in space. It was the expansion of space itself. Every point in the universe was once closer together, and every point continues to move away from every other. There is no center, no edge, only expansion. As the universe grows, it continues to cool and evolve. Stars form and die, galaxies merge and drift apart, and the cosmic web stretches ever wider. The laws born in that first instant still govern everything that happens today: the orbits of planets, the light of stars, the motion of galaxies. And yet, for all its vastness, the universe remains a single unfolding story, from the smallest quark to the largest supercluster, all connected by the same thread of existence that began at the Big Bang. If the universe had expanded only a little faster, matter would have spread too thin and no stars would have formed. If it had expanded a little slower, gravity would have pulled everything back into a single point. It is a delicate balance, one that allowed structure, life, and consciousness to emerge. The birth of the universe was not just the birth of space and time, but the birth of potential, the possibility for everything that would ever exist. From the collapse of quantum fields came atoms. From atoms came stars. From stars came planets. And from planets came beings capable of wondering about it all. We are not separate from that beginning. Every atom in our bodies was forged in the heart of ancient stars, and those stars were born from the elements created in the Big Bang. We are the universe made conscious, a way for it to look back at itself and ask, how did it all begin? As we reach the limits of our understanding, the story of the beginning remains both a scientific mystery and a poetic truth. The universe was born in a moment of unimaginable transformation, and everything that followed from galaxies to life is a continuation of that single act. And so, the universe expands still. The same forces that lit the first stars continue to shape the cosmos today. Each new discovery brings us closer to understanding not just how it began, but why it exists at all. The story of the beginning is not just the story of the universe, it is our story. For in that first flash of creation, in that endless surge of energy and time, the seed of everything that would ever be was planted, including us. We came from that moment, and in many ways, we are still part of it. Every breath we take, every thought we think, every light we see is a continuation of that first expansion, that eternal unfolding that began when nothing became everything. And though billions of years have passed since that instant, the universe still whispers its origin through the faint background glow that fills the night sky. A quiet reminder that all things, great and small, began from one singular burst of existence. The beginning of the universe was not an end, but a promise that from chaos could come order, from darkness could come light, and from nothing could come life. And as we continue to explore the cosmos, we are tracing the echoes of that first moment, the dawn of everything. Hundreds of thousands of years have passed since the universe first exploded into existence. The violent inferno of its birth has cooled, and the chaos of energy has begun to settle. The young cosmos, once opaque and blinding, is now filled with a dim red glow. Matter is spreading out, expanding into an endless sea of darkness. This is the era when the universe begins to calm, when light itself finally breaks free. In those early times, the universe was still a soup of particles, protons, neutrons, and electrons, all colliding and scattering photons in every direction. No light could travel far. Every attempt was met by another particle waiting to block its path. The universe, though glowing fiercely, was like a fog too thick for light to escape. As the expansion continued, the temperature dropped to around 3,000 degrees Kelvin, cool enough for something miraculous to happen. Electrons finally slowed down enough to bind with protons, forming the first stable atoms. Most of them were hydrogen, the simplest element in the universe, and some helium, with traces of lithium. For the first time, the universe became transparent. Light could move freely across space without being endlessly scattered. This was the moment of recombination, when matter and radiation parted ways. And from that separation, the first true light of the cosmos was born. The photons released during recombination still travel through the universe today. We can detect them as the cosmic microwave background, a faint radiation that fills the sky in every direction. It's the oldest light in existence, the universe's baby picture, captured 380,000 years after its birth. This light carries an ancient message. It reveals the faint ripples and patterns left behind by the first tiny fluctuations in density, the fingerprints of creation. Places with slightly more matter became the seeds of future galaxies. Places with less became the great cosmic voids. It's astonishing to think that from these almost invisible variations, all the stars, planets, and galaxies we know today would one day form. But after the light of recombination faded, a deep silence followed. There were no stars yet, no galaxies, no structures, only vast clouds of hydrogen and helium gas drifting in darkness. This was the cosmic dark age. The universe at this time was still expanding, and gravity was the only force shaping it. Slowly, over millions of years, tiny clumps of matter began to form. The regions that had slightly more density began pulling in more gas. Over time, these clouds grew larger and denser, setting the stage for something new, the birth of the first stars. But the road to that first light was long. As the gas clouds collapsed under their own gravity, friction heated them up at their centers, pressure rose until temperatures reached millions of degrees. When hydrogen atoms fused into helium, releasing bursts of energy, the first stars flickered into existence. And when they did, the universe changed forever. These first stars were unlike anything we see today. They were giants, hundreds of times more massive than the Sun. Their cores burned hot and fast, living only a few million years before collapsing into black holes or exploding as supernovae. Yet, in their brief lives, they created something vital, the first heavy elements before them. The universe contained only hydrogen, helium, and a touch of lithium. But their nuclear fires forged carbon, oxygen, and iron, the elements that would later make up planets, oceans, and living creatures. Their explosions scattered these elements into the surrounding gas, enriching it for the next generations of stars. Every new star that formed carried more complex chemistry, paving the way for more intricate structures in the cosmos. As the first stars ignited, their ultraviolet radiation began breaking apart hydrogen atoms around them, reionizing the universe. The Dark Age was ending. Once again, light spread across space, this time from stars rather than the Big Bang's fading afterglow. The birth of light and atoms was more than just a transition in physics. It was the moment the universe became visible for the first time. There was contrast, light and darkness, matter and emptiness. Gravity continued to shape everything. Gas clouds gathered together, forming the first galaxies, small and irregular at first, but growing over time as they collided and merged. In these early galaxies, star formation was intense, and the cosmos glowed brighter with each passing era. At the same time, dark matter, invisible and silent, created the cosmic skeleton. Though we can't see it, it made up most of the universe's mass, guiding the ordinary matter into place. Where dark matter was densest, galaxies formed. Where it was sparse, great voids stretched out. This interplay between light and shadow, seen and unseen, sculpted the structure of the universe we live in today. As the first generations of stars lived and died, black holes began to emerge from their ashes. Some of these grew rapidly, consuming gas and merging with others, becoming supermassive. They sat at the hearts of young galaxies, shaping their growth. Meanwhile, cosmic radiation continued to cool. The bright orange glow of recombination faded into red, then into microwave light. Today, that same light is nearly invisible to human eyes, but it still fills every corner of space, the echo of creation that has been traveling for nearly 14 billion years. As we study that light, we find clues about the universe's earliest conditions, its temperature, its density, even its age. Each measurement confirms that everything we see today once began as tiny ripples in an ocean of fire. The formation of atoms and the first light was not just the end of chaos, it was the beginning of structure. It marked the universe's transition from pure energy to tangible form. From that moment on, matter could clump together, forming stars, planets, and eventually, life. When we look up at the night sky, we are witnessing the legacy of that transition. Every beam of starlight, every galaxy shining in the darkness, owes its existence to the moment atoms first formed and photons were set free. It is poetic to think that the light we see from distant galaxies began its journey billions of years ago, long before our planet even existed. Each photon that reaches our eyes is a traveler from the dawn of time, carrying the story of a universe that has been expanding, cooling, and evolving ever since that first moment. And though the universe has grown vast and cold compared to its fiery beginning, it still glows faintly with the same light that was set free nearly 14 billion years ago. We live in a cosmos defined by that separation of light and matter, a universe that could finally see itself before this moment. There was only heat and chaos. After it, there was clarity, transparency, and the first true possibility of beauty. As the first atoms drifted freely through space, gravity began weaving its invisible threads. Clouds formed, stars prepared to ignite, and the stage was set for the next great transformation, the birth of the first generation of stars that would bring light, color, and complexity to the once dark universe. And so, from the ashes of chaos and the silence of emptiness, the cosmos prepared to awaken once again, this time not through fire, but through the eternal glow of the first stars. The universe, once a glowing fog of radiation, has now turned dark. Hundreds of millions of years have passed since the Big Bang. The first atoms drift silently through a vast, endless night. There are no stars yet, no galaxies, only a cold sea of hydrogen and helium stretching beyond imagination. This is the era known as the Cosmic Dark Ages. In this deep darkness, gravity begins its patient work. It pulls the slightly denser regions of gas, the tiny ripples left over from the early universe, closer together. These ripples, though small, are powerful seeds. Over millions of years, they grow denser and denser, forming enormous clouds of hydrogen that collapse under their own gravity. Inside these invisible clouds, pressure and heat begin to build. As the gas compresses, atoms collide more and more violently. At first, the heat is not enough to ignite anything, but as the core continues to shrink, the temperature rises to millions of degrees. Then, at last, hydrogen nuclei fuse into helium. In that instant, a star is born, the first light since the Big Bang bursts into existence. These stars, the first generation, known as population 3 stars, are nothing like the stars we see today. They are giants, monsters of light and fire. Some are hundreds of times the mass of the Sun. Their cores burn furiously, producing unimaginable heat and radiation. Their lives are short, mere millions of years, but during that brief time, they reshape the universe around them. Their ultraviolet radiation begins to break apart the hydrogen atoms that fill space, turning the universe from opaque darkness into a transparent, glowing realm once again. The process is called re-ionization, the awakening of the cosmos. As the first stars shine, they gather in groups, bound together by gravity. These clusters will become the earliest galaxies. They are small, irregular, and unstable, but they are the first organized structures in a universe that was once chaos. The first stars live fast and die violently. Many of them end their lives in supernova explosions, each one briefly outshining an entire galaxy. These explosions are not just spectacular, they are vital. Inside those massive stars, elements heavier than helium have been forged: carbon, oxygen, iron, and more. When the stars explode, they scatter these new elements into space. For the first time, the universe is no longer made only of hydrogen and helium. It now contains the ingredients for planets, for oceans, and one day, for life. The shock waves from those supernovae trigger the birth of new stars, creating a cosmic chain reaction. Each generation of stars enriches the universe further, making it more complex, more alive. As galaxies form and merge, the universe begins to glow with the light of countless stars. Cosmic filaments, vast structures made of dark matter and gas, begin to stretch between galaxy clusters. The great web of the universe starts to take shape. And deep within these early galaxies, at their very hearts, something even more mysterious forms the first black holes. Some of these are remnants of massive stars that collapsed after their explosions. Others form directly from collapsing gas clouds. Over time, they grow by feeding on nearby matter, becoming more and more massive. These early black holes unleash enormous energy as they consume gas and dust, creating bright quasars beacons that shine across billions of light years. Their light pierces the dark universe, marking the dawn of the first true cosmic structures. The age of the first stars is both violent and beautiful. Galaxies are still young and unstable, constantly crashing into one another. Each collision triggers bursts of new star formation. The universe is chaotic, yet every explosion and collapse brings more order, more structure. For the first time, the cosmos has color. Brilliant blue-white stars illuminate vast clouds of glowing gas. Supernovae paint the darkness with crimson and gold. Everywhere, energy flows, creation and destruction locked in eternal balance. While all this unfolds, dark matter, the invisible glue of the cosmos, continues shaping the universe on the largest scales. Though it emits no light, its gravity dictates where galaxies will form and how they will move. It builds a hidden framework upon which the visible universe grows. Within a few 100 million years, galaxies begin to take familiar shapes. Spirals and ellipticals emerge from the chaos, spinning gracefully through the expanding cosmos. Some of them contain billions of stars, orbiting like fireflies around their dark centers. As these galaxies mature, the balance between star birth and star death creates a steady rhythm, a heartbeat of the universe. The light from the first stars still travels through space today. When astronomers look through powerful telescopes, they can see that ancient light faint, redshifted by billions of years of cosmic expansion. Every photon from those early stars is a messenger from the dawn of time, telling us how the universe first came alive. The era of the first stars also marks the beginning of cosmic recycling. Nothing in the universe is wasted. The death of one generation of stars fuels the birth of the next. Heavy elements, forged in stellar cores, mix with clouds of gas, creating new stars and eventually planetary systems. The universe has begun a cycle of creation and renewal that will continue for billions of years. As more galaxies form and grow, they begin to cluster together, bound by the gravity of dark matter. Vast superclusters and filaments stretch across the cosmos, while enormous, empty regions, cosmic voids, open between them. The scale of the universe becomes almost beyond comprehension. Yet, amid this vastness, every structure, every star, every planet traces its existence back to this era, the time when the first stars ignited and brought light to the universe. Before this, the cosmos was silent, empty, and dark. After this, it becomes a living, luminous tapestry full of energy, movement, and complexity. The birth of the first stars marks the universe's first transformation from simplicity to richness. From a uniform fog of gas, it evolves into a cosmic landscape filled with dazzling beauty and endless diversity. And with the death of these first stars, the foundation for everything else is laid. Their remnants, black holes, heavy elements, and enriched gases become the raw materials for the next great era of cosmic evolution, the age of galaxies. As light spreads farther and farther across the cosmos, darkness retreats. The universe, once young and chaotic, now begins to organize itself into the vast and structured expanse we see today. The first stars may be long gone, their brilliance extinguished billions of years ago, but their legacy endures in every star that shines now, in every planet that orbits, and in every living being that looks up and wonders where it all began. The cosmic dawn has arrived, and the universe will never be the same again. Billions of years have passed since the first stars ignited and filled the cosmos with light. The universe has grown and matured, expanding and cooling as time flows on. Where once there was only darkness, now there are structures, vast, luminous collections of stars, gas, and dust. This is the age of galaxies, the great architects of the universe. The earliest galaxies were small and irregular, mere clusters of the first stars bound together by gravity. They flickered like fragile embers in the dark, constantly merging and colliding with one another. Over time, through countless collisions and gravitational interactions, they evolved into the grand spiral and elliptical galaxies we see today. It all began with dark matter, the invisible backbone of the cosmos. Though unseen, its gravitational pull shaped everything that followed. After the Big Bang, dark matter began to clump together into massive halos, invisible cocoons that served as gravitational wells. Ordinary matter, hydrogen and helium gas, fell into these wells, cooling and condensing to form stars. These stars gathered into galaxies, trapped within the gravitational embrace of dark matter. As more and more gas collected, the galaxies began to grow. Gravity became the great sculptor, pulling and twisting clouds of gas into swirling disks. Within those disks, new stars were born in bright clusters, illuminating their galactic homes. Some galaxies grew quickly, devouring their smaller neighbors in violent mergers. Each collision reshaped them, mixing their stars, warping their structure, and triggering bursts of star formation. Others remained isolated, evolving slowly and gracefully. The result was a dazzling variety of forms: majestic spirals with sweeping arms of starlight, compact ellipticals filled with ancient stars, and irregular galaxies distorted by cosmic interactions. At the hearts of many of these galaxies, something mysterious began to emerge. Black holes, not just the remnants of massive stars, but supermassive black holes millions or billions of times heavier than the Sun. They grew by consuming gas, stars, and even other black holes. As they fed, they released enormous energy, creating brilliant quasars that outshone entire galaxies. These quasars became cosmic lighthouses, visible across billions of light years. Their radiation shaped their surroundings, heating and pushing away gas, regulating star formation within their host galaxies. Though destructive, they were also creative, controlling the pace at which galaxies grew and evolved. In time, galaxies began to cluster together under the influence of gravity, forming enormous structures known as galaxy groups and clusters. The Milky Way, our home galaxy, is part of such a group, bound together with its neighbors, including the Andromeda Galaxy. The clusters did not exist in isolation. They were connected by vast filaments of dark matter and gas forming a cosmic web stretching across the entire universe. This immense structure, billions of light years wide, became the skeleton of the cosmos. Between these filaments lay enormous voids, regions almost completely empty, where galaxies are few and far between. As galaxies matured, their appearances reflected their histories. Spiral galaxies, like the Milky Way, continued forming stars, glowing with youthful blue light. Elliptical galaxies, having used up most of their gas, aged into massive, reddish orbs filled with older, dying stars. Irregular galaxies, often shaped by collisions, remained chaotic and asymmetrical. In this era, galaxies became the engines of cosmic evolution. Inside their dense clouds of dust and gas, stars were born by the billions. Each star lived its life, some burning for billions of years, others dying in spectacular explosions that scattered heavy elements into space. These elements, carbon, oxygen, silicon, and iron, enriched the interstellar medium, allowing the formation of rocky planets and, eventually, life. In the arms of these galaxies, new solar systems took shape, each with their own suns and planets. Some would remain barren and cold, others would evolve into places of warmth, chemistry, and potential. Though life was still rare and fragile, the building blocks were now everywhere. Meanwhile, galaxies continued to interact and evolve. Smaller galaxies were often consumed by larger ones, their stars merging into the greater whole. Each collision sent waves of gas and dust spiraling through space, igniting bursts of new star formation. Andromeda and the Milky Way, two great spirals, are slowly being drawn toward each other by gravity. In about 4 billion years, they will collide and merge into a single, giant, elliptical galaxy. Such collisions are common across the universe. They are part of its natural rhythm. Beyond individual galaxies, the cosmos itself kept changing. The expansion that began with the Big Bang continued, driven by a mysterious force called dark energy. As galaxies drifted farther apart, the large-scale structure of the universe began to settle. On small scales, gravity pulled galaxies together. On cosmic scales, expansion carried them away. From a simple cloud of hydrogen and helium, the universe had evolved into a grand masterpiece of light and structure. Billions of galaxies now filled space, each containing hundreds of billions of stars, each star surrounded by planets, moons, and dust. The scale was beyond comprehension, and yet every galaxy was connected, bound together by the invisible threads of dark matter woven into the cosmic web. These threads stretched across trillions of miles, forming patterns that mirrored the very fluctuations born in the earliest moments of creation. As we look out into the universe today, we see galaxies not as they are, but as they were ancient snapshots from billions of years ago. The light from distant galaxies began its journey long before Earth existed. Each one tells a story of creation, evolution, and change. The formation of galaxies was not just a step in cosmic evolution, it was the creation of the environments where everything else would unfold. Within their arms, stars would live and die, planets would form, and one day, life would awaken to ask where it all began. The galaxies became the universe's memory, vast libraries of light holding the history of everything. From the fiery birth of the first stars to the calm, steady glow of mature suns, they contained all stages of cosmic life. In their swirling arms and glowing cores, the elements of existence cycled endlessly, hydrogen to helium, helium to carbon, carbon to iron, and back again. Nothing was wasted, everything transformed. The age of galaxies was the age of order emerging from chaos. It was when the universe began to look like the one we see now, filled with beauty, complexity, and meaning. And though galaxies seem eternal, they too will change. In the distant future, star formation will slow, collisions will continue, and many galaxies will fade as their stars die. But for now, they are the vibrant heart of the cosmos, the grand islands of light in an ocean of darkness. And deep within one of those countless galaxies, in the quiet spiral arms of a star system not yet born, a small world will one day emerge. It will circle a yellow sun, covered in blue oceans and white clouds. It will be the beginning of a new kind of story, one where the universe begins to know itself. In the heart of countless galaxies scattered across the young universe, something dark, powerful, and mysterious is awakening. It is invisible to the eye, yet its presence can be felt everywhere, bending light, shaping galaxies, and swallowing entire stars whole. These are the supermassive black holes, the cosmic giants that rule the centers of galaxies and govern their fates. No one knows exactly how these colossal beings first formed. Some may have begun as the remnants of the first massive stars collapsing under their own gravity until not even light could escape. Others may have grown directly from enormous clouds of gas that collapsed before stars could even form. Whatever their origin, they began small and then grew beyond imagination. A black hole is not an object in the usual sense. It is a region of space where gravity has become so intense that everything, even light, is trapped. At its center lies the singularity, a point where the laws of physics break down, where density becomes infinite. Surrounding it is the event horizon, the invisible boundary of no return. Once something crosses that boundary, it is lost forever. But black holes are not just destroyers. Paradoxically, they are also creators. As gas and dust spiral toward them, they form accretion disks, swirling rings of superheated material spinning at near light speed. Friction and gravity tear the matter apart, releasing vast amounts of energy. Some of this energy escapes as powerful jets of radiation that shoot out from the poles of the black hole, stretching for thousands of light years. These jets, glowing brighter than billions of stars, can be seen across the universe. They are the engines of quasars, the most luminous objects in existence. Each quasar is powered by a supermassive black hole at its core, feeding on surrounding gas and releasing more light than entire galaxies combined. In the early universe, quasars were everywhere. Their light pierced the cosmic darkness, turning the universe into a glowing tapestry of energy and motion. Each one marked the heart of a growing galaxy, where the balance between destruction and creation shaped the future of stars and worlds. As black holes consumed matter, they grew. Small black holes merged to form larger ones, and galaxies collided, bringing their central monsters together in cosmic dances of unimaginable scale. When two supermassive black holes merged, they released gravitational waves, ripples in the very fabric of space-time that echoed across billions of light years. These cosmic mergers were violent yet essential. They helped galaxies grow larger and more stable. Each merger reshaped the stars around it, sometimes triggering waves of new star formation. At other times, the immense energy from a quasar would blow away surrounding gas, halting star birth and cooling the galaxy. Black holes, though invisible, acted as regulators, the heartbeat of galaxies. Too many stars, and the black hole's fury would reignite, clearing the way. Too few, and the gas would settle again, ready to form new stars. It was a delicate cosmic balance. The Milky Way, our home galaxy, carries such a monster at its center, called Sagittarius A*. It weighs about 4 million times the mass of the Sun. Though calm today, it too was once an active, ravenous quasar in the distant past. The scars of that ancient fury can still be seen in the glowing gas near its core. As the universe aged, the era of quasars began to fade. Galaxies grew larger, and their black holes, though still powerful, became quieter. Less gas was available to feed them, and the universe entered a calmer phase. Stars, planets, and solar systems began to take shape in the peaceful arms of these maturing galaxies. But the influence of black holes never ended. Even dormant, their gravity held galaxies together, keeping stars in stable orbits. They were the anchors of cosmic structure, ensuring that galaxies did not tear themselves apart over time. Scientists now know that nearly every large galaxy in the universe contains a supermassive black hole at its center, and the size of the black hole is closely linked to the size of its host galaxy. It is as though galaxies and their black holes grow together, each shaping the other through an invisible bond. In the heart of active galaxies, the dance between creation and destruction continues. Matter falls inward, light bursts outward, and gravity shapes everything around it. Black holes may be the most extreme objects in the universe, but they are also among the most essential. Without them, galaxies would not exist in the way we know them. The jets that shoot from black holes can stretch across entire galaxies, energizing surrounding gas and triggering new star formation. They distribute heavy elements across vast distances, enriching the cosmos with the materials needed for planets and life. Even their destructive power plays a creative role, ensuring that galaxies do not form too many stars too quickly, which would otherwise exhaust their gas and die young. Instead, black holes help galaxies evolve gracefully, regulating their life cycles across billions of years. In this way, black holes are both the universe's executioners and its caretakers. They destroy matter, yet their influence ensures that the cosmic cycle of birth, death, and rebirth continues endlessly. Today, astronomers can observe their effects, but not their true nature. Even light cannot escape their grasp, making them impossible to see directly. Only recently, with the Event Horizon telescope, have we captured the shadow of a black hole, a glowing ring of light surrounding a dark void, proof of their reality. And yet, for all our understanding, black holes remain mysteries. What lies beyond the event horizon? Does the singularity truly exist, or does quantum physics hide a deeper truth? Could black holes be gateways to other universes, or the seeds of new ones? Some theories suggest that every black hole might give birth to a new universe inside it, a daughter cosmos branching off from our own. If true, then the creation of black holes might also mean the creation of infinite universes, each with its own stars, galaxies, and laws of physics. From the first tiny collapses of matter after the Big Bang to the titans that now rest at the centers of galaxies, black holes have guided the universe's destiny. They are the silent rulers of time and space, shaping everything from the smallest atom to the largest supercluster. And though they consume light, they also define it. Though they represent endings, they also create beginnings. The story of the universe cannot be told without them, for they are its beating heart, its regulators, its destroyers, and its guardians. In the end, black holes remind us of one of the universe's greatest paradoxes, that from the deepest darkness, the brightest light is born. Deep within the ever-expanding cosmic ocean, one particular galaxy begins to take shape, the Milky Way. Born from countless collisions and mergers of smaller star systems, it grows into one of the most majestic and complex structures in the known universe. This is the story of our home, a vast spiral galaxy that would one day give birth to a star, a planet, and a species capable of asking where it all came from. In the beginning, the Milky Way was not a grand spiral. It started as a collection of small, irregular galaxies, each filled with clusters of ancient stars and swirling clouds of gas. Gravity drew these smaller systems together over billions of years, pulling them into larger and larger structures. As they merged, violent collisions scattered stars in every direction, reshaping their orbits and releasing immense energy. From this chaos, order slowly emerged. As the galaxy's rotation stabilized, the scattered stars began to settle into a disk-like shape, while older stars remained in a spherical halo surrounding it. Within this great spinning disk, dense clouds of gas began collapsing into new stars, lighting up the galaxy like a cosmic sunrise. At the heart of the Milky Way lay a growing black hole, Sagittarius A*. Though only a few million times the mass of the Sun, its gravity commanded the motions of everything nearby. Around it, stars moved at tremendous speeds, tracing invisible paths through the galactic core. This black hole had likely formed from the merger of many smaller ones, relics of the first stars that once burned in the early universe. Over time, the Milky Way became a masterpiece of balance and symmetry. Its spiral arms stretched outward, wrapping around a glowing central bulge. Within those arms, star formation flourished. Vast nebulae, immense clouds of gas and dust, gave birth to clusters of young, bright stars. Each one illuminated the surrounding gas, creating regions of breathtaking beauty. Within these stellar nurseries, the building blocks of future worlds began to form. The remains of older stars, heavy elements like carbon, oxygen, and iron, mixed with hydrogen and helium to create complex chemistry. Planets could now form around newborn stars, composed of rock, metal, and ice. The Milky Way became not just a collection of stars, but a cradle for creation. As the galaxy evolved, it continued to consume smaller companions. Dwarf galaxies that strayed too close were torn apart by its gravity, their stars and gas absorbed into the larger system. Remnants of these collisions still exist, streams of stars stretching across the sky, faint traces of the Milky Way's ancient feasts. In its outer reaches, dark matter continued to hold everything together. Invisible, yet powerful, it extended far beyond the visible disk, creating a massive halo that stabilized the galaxy's rotation. Without dark matter, the Milky Way's spiral arms would have torn apart long ago. At this point, the galaxy had matured into a vast system spanning more than 100,000 light-years across, containing hundreds of billions of stars. Yet it was still young by cosmic standards, constantly changing, forming, and evolving. Within one of its quiet spiral arms, the Orion arm, a new story was about to begin. Among clouds of gas and dust, a particular region began to collapse under gravity. This region would give birth to a star not particularly large or bright, but stable and long-lived. Around that star, debris would gather to form planets. One of those planets, covered in water and bathed in sunlight, would one day call itself Earth. But long before that, the Milky Way had already become a grand cosmic ecosystem. Stars were born, lived, and died in endless cycles. When massive stars exploded as supernovae, they enriched the surrounding space with heavy elements, providing the raw materials for the next generation of stars. It was a continuous process of destruction and creation, chaos and order. Some parts of the galaxy remained calm and stable, home to gentle sun-like stars. Others were wild and violent, filled with neutron stars, black holes, and supernova remnants. The Milky Way was a place of contrasts, beauty and danger, birth and death, light and darkness. As billions of years passed, the galaxy continued to grow. It began to form relationships with nearby galaxies, including its closest neighbor, Andromeda. The two were locked in a slow gravitational dance, drifting toward each other at incredible speeds. In about 4 billion years, they will collide, merging into one massive elliptical galaxy. It will be a spectacular event. Stars flung across space, black holes merging, new stars forming in the chaos. Even as the Milky Way moved through this cosmic ballet, its internal rhythm continued. New stars formed from clouds of gas, while older stars burned out and died. Globular clusters, ancient collections of stars, orbited the galactic core like sentinels from another era, relics of the early universe. And at the very center, Sagittarius A Times continued its silent watch. Though mostly dormant now, occasionally it stirred, flaring with bursts of X-rays as gas and dust ventured too close and were torn apart. It was a reminder that even in the heart of stability, immense power slept. The Milky Way, for all its vastness, is only one galaxy among trillions. Yet it is special not because of its size or beauty, but because it carries within it the conditions for life. Its calm outer arms provided safe havens, where stars like the sun could shine for billions of years without interference from violent neighbors. It was in one of these quiet corners that life would one day take hold. As the galaxy spun, stars traced elegant spirals through space, completing one full rotation every 230 million years. The sun, when it eventually formed, would take that same journey orbiting the galactic core more than 20 times in its lifetime. From afar, the Milky Way appeared as a glowing river of light stretching across the night sky. To the first beings who would someday gaze up from Earth, it would be a mystery, a bridge of stars, a path to eternity. But in truth, it was their home, their origin, and their destiny. The birth of the Milky Way was not a single event, but an ongoing process, a story of countless mergers, explosions, and transformations. It is still unfolding today, with new stars forming even as old ones fade. And though the galaxy seems eternal, it too will one day change. When the last stars burn out and darkness returns to the cosmos, the Milky Way will be but a faint echo of its former glory. Yet for now, it stands as one of the universe's grandest achievements, a testament to gravity's artistry and time's patience. Within its spiral arms, countless worlds circle countless suns. Some are barren and cold, others shimmer with oceans and clouds. And on one of them, deep within the quiet edge of a spiral arm, consciousness will awaken and begin to wonder about the very galaxy that made it possible. The story of the Milky Way is not just the story of a galaxy. It is the story of every star, every world, and every living thing that will ever rise within its light. It is the story of us. Within the grand spiraling arms of galaxies like the Milky Way, the cycle of creation continued endlessly. Clouds of hydrogen and helium, remnants of long-dead stars, drifted across the darkness, pulled and twisted by gravity until they began to collapse. Deep within these colossal clouds, the universe's most powerful engines of creation came to life once more. This was the birth of stars and planets, the next great chapter in the story of existence. A molecular cloud can stretch for hundreds of light years, but most of it is empty. Within it, however, lie dense knots, regions where gravity begins to overpower outward pressure. As these knots collapse, they spin, flattening into disks of gas and dust at their centers. Matter grows hotter and denser until the temperature reaches millions of degrees. Nuclear fusion ignites, and a star is born. Each newborn star is a beacon of light in the dark, It marks the transformation of invisible gas into radiant energy, the same process that has powered the universe since the first stars ignited billions of years earlier. Around these newborn stars, the leftover gas and dust do not vanish. Instead, they swirl into thin, rotating disks, the birthplaces of planets. Within these protoplanetary disks, countless grains of dust collide and stick together. At first, they are microscopic, no larger than specks of smoke. But over millions of years, through endless collisions and gravitational attraction, they grow into pebbles, rocks, and eventually planetesimals, the building blocks of worlds. The universe, once filled only with light and gas, now began to craft solid surfaces, mountains, oceans, and atmospheres. The raw material for planets was everywhere. In some systems, the heat from the young star vaporized nearby material, forming rocky planets close to the center. Farther away, where it was colder, gas giants took shape. Massive worlds made of hydrogen and helium. Beyond them, icy worlds and comets formed in the frozen outskirts. Each new solar system was a unique experiment of gravity and time. Some would remain stable for billions of years, while others would be torn apart by collisions or the pull of passing stars. But all of them began with the same dance: the collapse of a cloud, the ignition of a star, and the creation of a disk. As the first generations of stars lived and died, they filled the cosmos with heavier elements: carbon, nitrogen, oxygen, iron. With each new cycle of birth and death, the universe became more chemically rich. Later generations of stars formed in environments containing these elements, allowing rocky planets to exist. Without the ashes of ancient stars, no world like Earth could ever have formed. Stars, like living beings, go through lifetimes. Small stars burn slowly and live for tens of billions of years. They're light, gentle, and steady. Larger stars burn bright and fast, their fuel exhausted in just a few million years. When they die, they do so dramatically, exploding as supernovae and scattering their elements into the surrounding space. These explosions are not endings, but renewals. The heavy elements they release, gold, silver, calcium, and even the carbon in our bodies, are thrown into the interstellar medium, mixing with gas to form new stars and planets. It is a cosmic recycling system that never stops. From this process came diversity solar systems with different kinds of stars, planets with different sizes and atmospheres, and moons with oceans and volcanoes. Some worlds were covered in ice, others in clouds of fire. Some circled peacefully in stable orbits. Others were ejected into the dark void, becoming rogue planets, wandering the galaxy forever. Each planet was shaped by countless random events, collisions, migrations, and gravitational dances. In some systems, giant planets moved inward, scattering smaller ones and reshaping their orbits. In others, smaller rocky planets found perfect stability, orbiting quietly in zones where temperatures allowed liquid water to exist. And in those rare zones, the habitable zones, conditions for life became possible. The birth of stars and planets was not just a mechanical process, it was the beginning of cosmic complexity. For the first time, matter assembled into intricate structures, worlds capable of weather, geology, and chemistry. In the vast expanse of the galaxy, billions of such systems were forming. Each one was a potential story waiting to unfold. Within the Milky Way alone, over 100 billion stars shone, and around most of them, planets orbited silently. There were more planets than stars, countless chances for creation to repeat itself. The light from newborn stars illuminated the dusty regions they emerged from, forming glowing nebulae that painted the galaxy with color. The Orion Nebula, the Eagle Nebula, and others became the cradles of creation, vast stellar nurseries where stars were continuously born. As the universe aged, the balance between star birth and star death stabilized. Galaxies, like the Milky Way, became factories of creation, turning gas into stars at a steady rhythm. Every explosion of a dying star became the spark for a new generation. Inside these stars, the same nuclear reactions that began in the Big Bang continued, turning simple elements into complex ones. Hydrogen became helium, helium became carbon, carbon became oxygen and iron. This process of fusion, ongoing for billions of years, was how the universe built everything it contained. Planets, meanwhile, evolved in their own ways. Some developed thick atmospheres that trapped heat, others lost theirs to space. Some became gas giants with no solid surface, others became rocky worlds where chemistry could thrive. Among them, a few would host conditions just right for something extraordinary, the rise of life. But that moment was still far in the future. For now, the universe was busy perfecting its craft, mastering the art of forming stars and worlds. The interplay of gravity, radiation, and time turned chaos into structure, dust into planets, and light into energy that would sustain everything to come. And yet, as countless suns burned across the galaxy, each one carried a secret. Within its light and heat lay the potential for self-awareness, for life, for consciousness. The stars were not just beacons in the sky, they were creators. Every atom of every living being that would ever exist was once forged in the heart of a star. The calcium in our bones, the iron in our blood, the oxygen we breathe, all born from the same fiery furnaces that illuminated the early universe. In this way, the birth of stars and planets was not only a cosmic milestone, but also the foundation of life itself. The universe, once a storm of energy, had now become a place of harmony. Order emerged from chaos. Light gave birth to structure, and matter found its rhythm. The great cycle of creation, birth, death, and rebirth, was in full motion. And within the arms of the Milky Way, among billions of suns, one particular system would soon form, destined to become the cradle of intelligent life, the home of a world that would look back and try to understand it all. The stage was set. The sun was about to rise. About 9 billion years after the Big Bang, in one quiet corner of the Milky Way galaxy, a new star began to form inside a dense cloud of dust and gas. It was an unremarkable event in a universe filled with billions of stars. But this one would become something special. From the remnants of ancient supernovae and cosmic dust, our sun was born. And with it, the solar system, a collection of worlds that would one day include Earth, the only planet known to harbor life. It began inside a molecular cloud, rich in elements forged by generations of dead stars: hydrogen, helium, carbon, oxygen, silicon, and iron. Gravity caused the cloud to collapse inward, forming a dense, spinning disk in its center. Pressure and temperature rose until nuclear fusion ignited. The sun came to life, its blinding light pushing away the remaining gas and announcing the birth of a new star. Around it, the leftover material, billions of tons of dust and rock, continued to orbit. Collisions among these particles caused them to clump together, forming larger and larger bodies. Some of them grew into planetesimals, then into protoplanets, their gravity sweeping up surrounding material. Close to the sun, where heat was intense, only metals and rocks could survive. Here, the terrestrial planets, Mercury, Venus, Earth, and Mars, took shape. Farther away, in the colder regions, ices of water, methane, and ammonia were abundant, giving rise to the giant planets Jupiter, Saturn, Uranus, and Neptune. Beyond them, the icy debris of comets and dwarf planets formed the Kuiper Belt and the distant Oort cloud. The early solar system was chaotic. Collisions were constant, and the young planets often changed orbits. Asteroids bombarded the inner worlds, leaving scars that can still be seen today. Some protoplanets were destroyed, while others merged to form larger bodies. One such collision gave birth to Earth's moon, when a Mars-sized object struck the early Earth and ejected debris that eventually coalesced into a companion. In these violent beginnings, the foundation for stability was being laid. Gravity slowly calmed the chaos, clearing the solar system of leftover debris. The planets settled into nearly circular orbits, and the system entered a long period of calm, one that would last for billions of years. The Sun itself became a symbol of balance. It burned steadily, powered by the fusion of hydrogen into helium in its core. Every second, it released more energy than humanity would ever produce in its entire existence. This energy spread throughout the solar system, warming planets, driving winds, and shaping atmospheres. Each world that formed around the Sun developed its own character. Mercury, the closest, became a scorched, cratered wasteland. Venus turned into a greenhouse inferno, its atmosphere thick with carbon dioxide. Mars, once warm and wet, lost its atmosphere and froze. Jupiter grew enormous, swallowing gas and debris, becoming the solar system's giant guardian. Saturn formed with its magnificent rings of ice and rock. Uranus and Neptune became cold, distant orbs of gas and ice. And then there was Earth, a rocky planet at just the right distance from the Sun, not too hot, not too cold. Its surface cooled, forming oceans, mountains, and continents. Volcanoes filled its early sky with gases that would one day form its atmosphere. In time, this small blue world would become the only known place in the universe to awaken with life. But before life, there was chemistry. The elements forged in ancient stars mixed and reacted in Earth's young oceans. Lightning strikes and volcanic heat-powered reactions that turned simple molecules into complex ones. These reactions would eventually give rise to the first living cells, but that part of the story was still billions of years away. Meanwhile, the solar system continued to evolve. Asteroids and comets bombarded the planets, delivering water and organic molecules to Earth and perhaps to other worlds. The heavy bombardment shaped surfaces and atmospheres, setting the stage for the evolution of stable environments. The Sun, though peaceful now, was once far more active. Massive solar flares and radiation storms frequently erupted from its surface, sending waves of charged particles through the solar system. Yet, this very activity may have helped shape planetary atmospheres and magnetospheres, contributing to the development of habitable conditions on certain worlds. In this dynamic environment, balance eventually emerged. The planets, moons, and countless smaller bodies settled into predictable orbits. The solar system became a cosmic symphony, each object moving in harmony, guided by the Sun's gravity. From a wider view, the formation of the solar system was just one of billions happening throughout the galaxy. Yet every star system was unique. Some stars had multiple suns. Others had worlds far larger or smaller than ours. Some had no planets at all. In our case, the balance between chaos and stability, heat and distance, destruction and creation, produced something extraordinary. The birth of the Sun and the solar system was not merely the creation of planets, it was the setting of the stage for consciousness itself. Every atom that would one day form human life, carbon, nitrogen, oxygen, iron, was already present in that swirling disk of dust and gas. As the solar system aged, it became a stable environment in a universe filled with turbulence. It provided the long-term calm needed for life to evolve. Billions of years later, one of its planets would look back across time and realize that its very existence was the result of cosmic recycling, that everything it was made of had once burned in the heart of a star. The creation of the solar system was both violent and beautiful, a cosmic act of balance where destruction paved the way for creation and chaos gave rise to order. The same processes that shaped our world continue throughout the galaxy even now. Stars are still forming in distant nebulae, their light reaching us across millennia. Around them, new planets are being born, some destined to remain barren, others perhaps waiting to awaken with life of their own. The sun, like all stars, will not shine forever. One day, billions of years from now, it will expand into a red giant, swallowing the inner planets before shrinking into a white dwarf, a fading ember of what it once was. But for now, it burns with perfect steadiness, sustaining life on a single, fragile world that floats in the vastness of space. The story of our solar system is the story of balance in motion, of light and gravity, fire and ice, chaos and peace. From the dust of dead stars came the sun, and from the debris of creation came the planets. And from one of those planets, life would emerge, life that would one day look to the stars and realize they were its ancestors. The birth of the sun and the solar system was not an isolated event. It was the continuation of the universe's grand pattern, the endless cycle of birth, death, and rebirth. Every atom in our world carries that legacy. Every element a memory of the stars that came before. And as the planets settled into their eternal dance around the sun, the next great chapter in the story of the universe was about to begin the rise of life on a young blue world called Earth. The young Earth was a hostile world, a planet newly born from fire and chaos. Its surface was molten, covered with seas of lava, and shrouded in thick clouds of toxic gas. Comets and asteroids bombarded it constantly, their impacts releasing colossal energy, shaking the planet to its core. Yet, within this chaos, the foundations for something extraordinary were being laid, the birth of life. About 4.5 billion years ago, Earth formed from the dust and debris left over after the sun's creation. For hundreds of millions of years, it endured relentless bombardment by asteroids, which delivered both destruction and vital ingredients, water, carbon, nitrogen, and other elements necessary for life. As the surface began to cool, rain fell for the first time. Oceans formed, covering most of the planet's surface. Volcanic eruptions filled the air with gases, forming a primitive atmosphere rich in carbon dioxide, methane, and ammonia. There was no oxygen, no blue skies, no continents teeming with forests, only dark oceans beneath a red sky. Yet these oceans became the perfect laboratory for chemistry. Within them, simple molecules began to interact. Lightning, volcanic heat, and ultraviolet radiation from the young sun provided the energy to drive these reactions. In this vast chemical soup, molecules combined into more complex structures, amino acids, lipids, and nucleotides. These were the building blocks of life. Somewhere within the depths of these ancient seas, a miracle occurred. Molecules began to replicate. The first forms of life were not creatures as we know them, but tiny, self-replicating chemical systems, fragile, microscopic, and simple. Over time, they became enclosed within membranes, creating the first primitive cells life had begun. These early cells, called prokaryotes, were the ancestors of all living things. They fed on simple chemicals in their environment and thrived in the harsh conditions of the young planet. Some of them learned to harness sunlight for energy, evolving the ability to perform photosynthesis. With this new power, they began to transform the planet itself. Photosynthetic bacteria released oxygen as a waste product, slowly filling the atmosphere with this new gas. For millions of years, the oxygen combined with iron in the oceans, forming bands of rust that settled on the ocean floor. Eventually, the iron was used up and oxygen began to accumulate in the air. This event, known as the Great Oxygenation, changed everything. Oxygen made it possible for life to evolve in new ways, to become more complex and energetic. But it was also deadly to many early organisms that could not survive in its presence. Mass extinction followed. Yet from that destruction came evolution. Deep within the oceans, life adapted. Single-celled organisms began to cooperate, forming colonies and sharing functions. Some cells specialized, one for movement, another for energy, another for protection. From this cooperation emerged multicellular life. The oceans became filled with new forms, soft-bodied creatures that swam, crawled, and filtered nutrients. Over hundreds of millions of years, evolution refined them, turning simple structures into complex ones. The first animals appeared, followed by plants and fungi. The seafloor became alive with color and motion. On the surface, the planet also changed. Volcanoes and tectonic forces created continents. Rain and wind carved rivers and valleys. The sky, once red with carbon dioxide, turned blue as oxygen filled the air. The Earth had transformed from a barren wasteland into a living, breathing world. Life continued to diversify, shaped by time and pressure. Mass extinctions would occasionally wipe out entire species, but each time, new life would emerge, more adapted and resilient than before. The story of life is one of persistence, of tiny, fragile cells surviving against impossible odds, adapting to every challenge. And yet, life's origin remains one of the greatest mysteries. How did non-living matter cross the threshold into biology? How did chemistry become consciousness? Scientists have many theories, but the answer may forever remain hidden in the depths of time. Perhaps the spark came from deep-sea hydrothermal vents, where minerals and heat created the right conditions for complex molecules to form. Perhaps it arrived from space, carried by comets, a theory known as panspermia. Or perhaps life is an inevitable consequence of the universe itself, a natural outcome of matter-seeking structure. Whatever the truth, once life began, it never stopped evolving. For billions of years, bacteria and simple organisms ruled the Earth. They built stromatolites, layered colonies that still exist today as living fossils. They shaped the atmosphere, the oceans, and the soil. Everything that would come after every plant, every animal, every human began with them. The transformation of Earth by life also affected its climate. The spread of photosynthetic organisms cooled the planet, while volcanic eruptions and asteroid impacts periodically warmed it. The planet's temperature rose and fell, but life endured through every cycle. Eventually, life left the oceans. Plants began to colonize land, creating new ecosystems. Animals followed, adapting lungs for breathing air and limbs for walking. The surface of the planet, once barren and silent, became alive with sound and movement. The rise of life turned Earth into a jewel of color and complexity. Blues of oceans, greens of forests, whites of clouds, all products of biological activity. When we look at our planet today, we see the result of billions of years of evolution and transformation. From the simplest molecules to complex organisms, every living thing shares a common ancestry, a single origin in the distant past. And yet, even after all this time, life on Earth remains deeply connected to the cosmos. Every atom in every cell was forged in the heart of a star. Every chemical reaction within our bodies follows the same laws that govern galaxies. Life is the universe made aware of itself, a continuation of cosmic evolution in biological form. The birth of life on Earth marked a turning point, not just for our planet, but for the universe itself. For the first time, matter could reflect, think, and wonder about its own origins. The young Earth, once just another planet circling an ordinary star, had become something far greater, a living world capable of giving rise to intelligence, emotion, and consciousness. And though life began small and fragile, it would one day shape entire continents, alter the atmosphere, and reach beyond the planet that gave it birth. The universe had created life, and through life, it would soon begin to understand itself. Billions of years after the first spark of life ignited on Earth, the world had changed beyond recognition. The once barren planet now teemed with forests, oceans, and creatures of every form imaginable, from microscopic bacteria to towering dinosaurs. From the depths of the seas to the peaks of mountains, life had conquered every corner of the planet. And then, from this grand tapestry of evolution, something new emerged: intelligence. It began slowly, through the silent work of evolution. Survival favored adaptation, and adaptation favored complexity. Among the countless species that roamed the Earth, one lineage of primates developed not only strength and dexterity, but also awareness. These early humans began to observe, to learn, and to question. Their curiosity set them apart from every other creature that had come before. For the first time in the history of the universe, a species looked at the stars and wondered what they were. Humans evolved on the African plains, learning to walk upright, freeing their hands to craft tools. They tamed fire, learned to communicate, and formed communities. As generations passed, their knowledge grew. They painted their thoughts on cave walls, passed down stories, and began to shape the world around them. Over thousands of years, humanity spread across the globe. Civilizations rose and fell: Egypt, Mesopotamia, Greece, Rome, China, and countless others. Each one added to humanity's growing understanding of the universe. They learned to farm, to write, to build cities, and to record the movements of the heavens. The night sky became their first window into the infinite. Early astronomers mapped the stars, tracked eclipses, and watched the wandering planets. They built monuments aligned with the solstices, from Stonehenge to the pyramids, blending wonder with science long before the two were separated by language. As human thought evolved, so did technology. The invention of the telescope opened a new chapter in the relationship between humanity and the cosmos. Galileo, with his simple glass lenses, revealed that the moon was not a perfect sphere, but a world of mountains and valleys. He saw moons orbiting Jupiter, proving that not everything revolved around Earth. In those moments, humanity's understanding of its place in the universe changed forever. The Earth was not the center of creation. It was one planet among many, orbiting an ordinary star within an ordinary galaxy in an unfathomably vast cosmos. Centuries later, scientists like Newton, Kepler, and Einstein would deepen that understanding. Gravity, once a mysterious force, became the thread that wove the universe together. Light, energy, and time themselves were revealed to be part of a single, elegant framework. Humanity began to see not just what the universe looked like, but how it worked. And yet, with every discovery, the mystery only deepened. For every question answered, new ones emerged. What came before the Big Bang? Are we alone in the cosmos? How does consciousness arise from matter? These questions pushed humanity further, driving it to explore beyond its home planet. With fire and metal, humans built machines that could fly with rockets. They broke free from Earth's gravity, stepping onto the moon for the first time in 1969. That moment was more than an achievement of engineering. It was a symbolic act, the universe touching itself through its own creation. As astronauts looked back at the Earth, they saw a small blue world suspended in blackness, fragile, unified, and alive. The image of that tiny sphere changed human perspective forever. Borders, nations, and conflicts seemed insignificant compared to the vastness of the cosmos. Human civilization continued to advance. Technology connected continents, knowledge spread across the planet, and scientific progress accelerated faster than ever before. Telescopes like Hubble revealed the farthest galaxies, while spacecraft like Voyager journeyed beyond the solar system, carrying golden records, messages of music, mathematics, and humanity into the stars. For the first time, a species was not only observing the universe, but also reaching out to it, seeking to make contact with whatever might exist beyond. Radio signals were sent into the void, carrying greetings in countless languages. The search for extraterrestrial intelligence began, a testament to humanity's desire not to be alone. Through science, humanity came to understand that everything, the stars, the galaxies, and even life itself, was made of the same elements. The carbon in human cells was born in ancient stars. The iron in their blood was forged in supernovae. Every atom in every person was once part of the universe's earliest fire. We are, as Carl Sagan once said, the universe made conscious. This realization connected humanity not only to the cosmos, but also to time itself. Each of us carries within us the memory of the universe, a lineage stretching from the Big Bang to the present moment. But with knowledge came responsibility. Humans discovered that they could alter the balance of their planet. The same curiosity that built civilizations also brought danger, war, pollution, and extinction. The power to destroy had arrived alongside the power to create. Still, the pursuit of understanding never stopped. Space telescopes scanned for exoplanets, worlds orbiting distant suns. Robotic explorers roamed Mars, Europa, and Titan, searching for signs of life. Quantum physicists probed the smallest particles of reality, while cosmologists studied the fabric of space-time itself. Humanity had become the storyteller of the universe, not separate from it, but part of it. Through thought and imagination, it could now comprehend the stars, even as it remained bound to a tiny world circling one of them. The rise of intelligence was not just an evolutionary milestone, it was the awakening of the cosmos itself. For the first time, the universe had beings capable of understanding its history and speculating on its destiny. Civilizations may rise and fall, stars may be born and die, but knowledge once gained endures. It travels in books, in data, in memories, and in light. Long after humanity itself is gone, the traces of its curiosity will drift among the stars, encoded in radio waves, digital signals, and the faint glimmer of machines exploring deep space. And perhaps, somewhere out there, another intelligent civilization will one day intercept those signals and realize that they, too, are not alone. The rise of intelligence marks the beginning of a new phase in the story of the universe, one in which understanding itself becomes part of evolution. Life had looked up, and for the first time, the universe had seen its own reflection. And though humanity's story is still young, it is forever woven into the cosmic fabric, a whisper of thought in an endless sea of stars. As humanity's knowledge expanded beyond the boundaries of its blue planet, a new age began, the age of exploration beyond Earth. For the first time in the history of life, a species was no longer confined to its home world. The same curiosity that once led humans across oceans now drew them toward the stars. The future of humanity would no longer be written only on Earth, but across the vast expanse of the cosmos. The journey began with rockets, crude yet powerful, breaking through the thin veil of the atmosphere. What once was impossible to escape, the pull of gravity, became a reality. Satellites orbited the planet, sending back images of weather patterns, continents, and storms. Humanity, for the first time, saw its world as one fragile, beautiful, and alone in the darkness. The first humans to venture into space were pioneers of a new frontier. They floated above the Earth, weightless and silent, gazing upon the curve of the horizon. It was an experience that forever changed human perspective. Boundaries that once divided nations disappeared beneath them from space. There were no borders, no wars, only a single planet glowing with life. Then came the moon. In July 1969, humankind took its first steps on another world. As the astronauts walked across the silent dust, they left behind footprints that would last for millions of years. Those footprints were not just marks in the lunar soil. They were symbols of possibility, proof that humanity could reach beyond its origins. But the moon was only the beginning. Mars became the next dream, a world that once might have held water, and perhaps even life. Robotic explorers landed there, sending back images of red deserts and distant mountains. Scientists began to imagine a future where humans could walk those plains, build colonies, and terraform the planet to make it habitable once again. Beyond Mars lay the gas giants Jupiter and Saturn, immense and majestic, their moons swirling like miniature solar systems. Missions like Voyager, Cassini, and Juno revealed worlds of stunning beauty and mystery. Europa with its subsurface ocean, Titan with its methane lakes, and Enceladus with its icy geysers. Each one held the possibility that life might exist in some hidden form, beneath ice, within oceans, or in chemical reactions deep underground. As exploration advanced, humanity began to think even bigger. Telescopes detected thousands of exoplanets orbiting distant stars, some in regions where conditions might be right for life. The search for another Earth, another home, became a defining quest of civilization. Technologies evolved to make that dream more real. Nuclear propulsion, ion drives, and the early concepts of warp technology promised journeys beyond the solar system. While true interstellar travel remained far away, robotic probes continued to push the boundaries. Voyager 1, launched in 1977, became the first human-made object to leave the solar system, carrying with it a message, a golden record containing the sounds and music of Earth. Somewhere, billions of years from now, that tiny spacecraft will still be drifting through interstellar space long after humanity is gone, still carrying the story of who we were. As humans reached further into space, they also looked inward, reflecting on what it meant to exist in a universe so vast. Space exploration was not just about discovery, it was about meaning. By exploring the cosmos, humanity was learning more about itself, its fragility, its creativity, and its purpose. Colonization became the next step. Space stations in orbit served as the first permanent homes beyond Earth. The International Space Station, a joint effort between nations, became a symbol of unity, proof that cooperation, not conflict, could propel civilization forward. On the Moon and Mars, bases began to rise from dust and ice. Solar arrays stretched across barren plains, and greenhouses grew the first crops under alien skies. Humanity had taken its first steps toward becoming a multiplanetary species. But the path forward was not without challenges. Space was unforgiving, radiation, isolation, and vast distances threatened every mission. Resources were limited, and survival required both innovation and unity. Humanity learned that to thrive beyond Earth, it had to evolve not biologically, but socially and intellectually. Artificial intelligence, robotics, and biotechnology became essential allies. Machines repaired spacecraft, mined asteroids, and explored environments too harsh for humans. Genetic engineering helped adapt life for new worlds, creating plants that could survive in Martian soil or resist cosmic radiation. As humanity spread through the solar system, its concept of home began to change. Earth remained the cradle of civilization, but no longer its only home. Mars, the Moon, and orbiting colonies became extensions of humanity, new branches of an ever-growing tree. And with this expansion came new philosophy. For the first time, people began to see themselves not just as citizens of nations or inhabitants of Earth, but as citizens of the universe. The stars became destinations, not distant lights. The boundaries of the possible stretched farther than ever before. Beyond exploration and colonization, a deeper question began to emerge. Could humanity survive the death of its own sun? Even the mightiest stars eventually fade, and the sun too would one day exhaust its fuel. It was inevitable. To endure, humanity would need to find a way to move beyond the solar system to travel to other stars. Theoretical concepts like generation ships, cryogenic travel, and digital consciousness offered possible solutions. Enormous vessels carrying entire societies could travel between stars over millennia, or perhaps humans could upload their minds into machines, allowing consciousness to journey where bodies could not. Though still in the realm of imagination, these ideas carried the essence of human ambition, the will to continue, to evolve, to never stop seeking. And while the stars seemed impossibly far, humanity's greatest strength was patience. The same patience that allowed life to evolve on Earth for billions of years would carry it forward through the ages of space. As the descendants of Earth spread across the galaxy, they would carry with them the same questions that had driven their ancestors. Who are we? Where did we come from? And are we alone? Perhaps on some distant world orbiting another sun, they would find their answer. The future of humanity in space is not a dream of conquest, but of connection, a continuation of the universe's own evolution. From stardust to consciousness, from Earth to the stars, the journey has always been about the same thing, the universe discovering itself. For now, the human race stands at the threshold, looking outward into the infinite. The stars are waiting, silent and eternal, just as they were when the first humans looked up from the savannah. But this time, humanity does not only look, it moves, it travels, it reaches. And somewhere, in the endless night, a new dawn begins, not on Earth, but among the stars. Every star that has ever burned across the heavens carries within it a hidden truth that even the brightest light must one day fade. Stars, the engines of the cosmos, are not eternal. They are born, they live, and they die, each one shaping the universe in its own way. Their life cycles are the heartbeat of creation itself, for in their deaths, they give rise to everything that follows the elements of planets, the chemistry of life, and the very matter from which we are made. This is the story of the death of stars, and how endings in the universe are never truly final. A star's life begins as a cloud of gas and dust collapsing under gravity. But once fusion ignites, the balance between gravity pulling inward and pressure pushing outward creates stability. For millions, billions, or even trillions of years, that balance holds. The star shines, transforming hydrogen into helium and releasing light and heat into the cosmos. But no fuel lasts forever. When the hydrogen in a star's core runs out, gravity begins to win. The core contracts, heating up as it compresses. For smaller stars, like our Sun, this marks the beginning of a slow, graceful decline. For massive stars, it is the start of something violent, spectacular, and cataclysmic. Stars the size of our Sun swell into red giants as their cores shrink and their outer layers expand. Their heat dims and reddens, their size growing hundreds of times larger than before. In this phase, they shed vast amounts of gas and dust into space, forming glowing clouds known as planetary nebulae. These beautiful, colorful structures, shaped like rings, bubbles, or wings, are the final breaths of dying stars. Inside the core, fusion continues in layers, helium fusing into carbon and oxygen, until finally, even that fuel runs out. With nothing left to burn, the outer layers drift away and the star's heart is left behind, a dense, glowing ember called a white dwarf. A white dwarf is small, roughly the size of Earth, but it contains nearly the mass of the Sun. Its gravity is immense, its surface hotter than any furnace. It will shine dimly for billions of years, slowly cooling, fading, and eventually becoming a black dwarf, a cold, dark remnant, no longer burning, no longer glowing, but still existing. For massive stars, however, the end comes differently. They live fast and die young, their lifespans measured in only millions of years. When fusion reaches its limit, when iron forms in the core, an element that cannot produce energy through fusion, the star's delicate balance collapses in an instant. Gravity crushes the core inward, and the outer layers fall violently onto it, rebounding in a colossal explosion, a supernova. In a single moment, the star releases more energy than the Sun will emit in its entire lifetime. This explosion scatters the elements the star has created across space: gold, silver, calcium, iron, carbon. Every atom, heavier than hydrogen, owes its existence to these cosmic deaths. Our bones, our blood, our world, all forged in the crucible of dying stars. What remains after the explosion depends on the star's mass. Smaller, massive stars leave behind neutron stars objects so dense that a single teaspoon of their material would weigh billions of tons. These neutron stars often spin rapidly, releasing beams of radiation that sweep across space like cosmic lighthouses. We call them pulsars. But if the star was truly massive, many times larger than the Sun, even neutron stars cannot withstand the crushing force of gravity. The core collapses further, shrinking beyond comprehension, creating a black hole. Space itself folds inward, and time distorts. Nothing can escape, not even light. In their death, these stars leave behind the universe's most mysterious objects. And yet, death in the cosmos is not destruction, it is transformation. The material expelled by dying stars forms vast nebulae, glowing clouds that will one day collapse to form new stars and planets. Within those clouds, the cycle begins again. The ashes of one generation become the seeds of the next. Every sunrise, every candle, every living cell on Earth is powered by energy once born in stars that died billions of years ago. When we look up at the night sky, we are not only seeing stars that live, but also the ghosts of those that have died. their light still crossing the cosmos long after their flames have gone out. Over time, as galaxies evolve, the number of new stars forming begins to decline. The gas needed for creation becomes scarce, consumed by earlier generations or blown away by supernovae and black hole jets. The universe, once filled with the brilliant light of newborn stars, slowly begins to dim. But even as individual stars die, their remnants, white dwarfs, neutron stars, and black holes continue to shape the cosmos. Some drift silently through space, while others collide, merging in bursts of gravitational waves that ripple through space-time itself. Each event leaves a mark, each death a new beginning. The death of stars also marks the birth of worlds. Supernova explosions enrich surrounding gas clouds with heavy elements, allowing rocky planets like Earth to form. Without stellar death, there would be no planets, no oceans, no life. In the grand scale of the universe, the death of a star is as vital as its birth. It is a reminder that endings are woven into creation, that destruction is not the opposite of life, but its continuation. As the universe grows older, fewer stars are born, and the galaxies grow dimmer. One day, even the last stars will exhaust their fuel. The cosmos will become colder, darker, and quieter. But until that far future, the light of dying stars will continue to blaze across the heavens, illuminating the darkness and reminding every living being that the energy of creation and destruction are one and the same. We live because stars die. We shine because they once did. The atoms that make up every human, every mountain, every ocean are ancient, the recycled remnants of countless stars that lived and perished before the Earth was even born. The death of stars is not the end of the story, but its heartbeat, the pulse that drives cosmic evolution forward. From their ashes rise new worlds, new suns, and new chances for life. And so the universe continues, each death giving way to life, each collapse giving birth to light. In the end, the stars are not gone. They live on in us, in our world, and in the endless night sky that will forever tell their story. Billions of years have passed since the first galaxies began to shimmer in the darkness. The universe, once young and full of brilliant light, is now middle-aged, still magnificent, but slowly changing. The great dance of creation and destruction continues, but the tempo has begun to slow. Galaxies that once grew rapidly and collided frequently now drift farther apart. Star birth, once fierce and abundant, begins to fade. The cosmos is entering a quieter era, the long twilight of galactic evolution. In this age, galaxies have reached their full splendor. Spiral galaxies like the Milky Way spread their arms gracefully across the void, glowing with billions of stars. Elliptical galaxies, massive and ancient, shine with the soft red light of old suns that no longer form new stars. Everywhere, galaxies cluster together in vast cosmic webs, bound by the invisible pull of dark matter. Yet, even amid this grandeur, change is inevitable. Gravity, though patient, never stops working. Galaxies that drift close enough to each other begin to merge, their shapes warping and twisting in the process. When two galaxies collide, their stars rarely crash directly. Space is too vast, but their gas and dust do. The collision compresses the gas, triggering waves of star formation that light up the merging galaxies like fireworks. This process is both beautiful and destructive. The violent merging of galaxies can tear apart spiral arms, fling stars into intergalactic space, and create immense bursts of radiation as black holes feed on the chaos. Yet from the wreckage, new forms emerge. Massive elliptical galaxies, filled with ancient stars and little gas left for future creation. In our own cosmic neighborhood, The Milky Way and the Andromeda Galaxy are destined for such a fate. Drawn together by gravity, they are on a slow collision course, moving toward one another at hundreds of kilometers per second. In about 4 billion years, they will collide and merge, their stars intermingling, their central black holes spiraling inward, until they, too, combine into one. The result will be a single vast elliptical galaxy. Astronomers call it Milky Way. For a brief time, the night sky of any surviving worlds will be filled with dazzling light, streams of stars, glowing clouds of gas, and immense tidal tails stretching across the heavens. But as the chaos settles, the new galaxy will grow quiet. Star formation will cease, and the remaining stars will age and fade. Beyond this grand merger, the universe continues to expand, stretching space itself. Dark energy, the mysterious force driving this expansion, causes galaxies to move away from one another faster and faster. Distant galaxies drift beyond the cosmic horizon, disappearing from view forever. Their light can no longer reach us. The universe, once full of brilliant connections, begins to grow isolated. Each surviving cluster of galaxies becomes an island, separated by ever-widening oceans of emptiness. Over time, these islands too will dissolve as gravity binds their galaxies ever more tightly together until they merge into one. The cosmic web that once linked galaxies across billions of light years begins to unravel. The great filaments that stretched between galaxy clusters thin out, while the vast voids between them grow even larger. As star formation declines, the galaxies begin to fade. Young, blue stars disappear first, leaving behind the older, red ones. The light of the universe reddens as it ages, shifting toward infrared. The cosmos that once burned with youthful brilliance becomes dim and subdued, a vast sea of dying light. Inside galaxies, the balance between creation and destruction shifts. Supernovae become rare. Black holes, having consumed most of the available gas, grow silent. Without fresh material to feed them, they enter long periods of dormancy. Their surrounding galaxies, now devoid of gas, slowly drift into stillness. The Milky Way, or what remains of it within Milkomeda, will one day be a galaxy filled mostly with red dwarf stars, small, cool, and long-lived. These faint suns will burn for trillions of years, far longer than the universe has existed so far. Though dim, they will continue to shine in the cosmic night, keeping the memory of starlight alive. But even these stars are not eternal. When their fuel finally runs out, they will fade into black dwarfs, cold, dark remnants. Galaxies will grow darker and colder as one by one their lights go out. The death of galaxies mirrors the death of stars. Not sudden, but slow and inevitable. It is a cosmic aging process, driven by the same forces that once created them. The same gravity that pulled matter together now disperses it into the ever-expanding void. And yet, even as the light fades, the story of the galaxies remains one of beauty. Their remnants, black holes, white dwarfs, neutron stars continue to exist, marking the silent memory of what once was. Occasionally, two remnants collide, releasing brief flashes of light and gravitational waves, reminders that even in the universe's twilight, motion and energy persist. In the distant future, long after the last major collisions have ended, galaxies will no longer form new stars. They will drift quietly through the darkness, illuminated only by the dying embers of their oldest suns. The once vibrant universe will have become a place of quiet dignity, a vast cathedral of ancient light slowly fading into silence. And yet, it is within this stillness that the meaning of the cosmos becomes clear. For from its birth, in a burst of unimaginable energy, to its slow, graceful decline, the universe has always been a cycle of creation, transformation, and release. Galaxies were never meant to last forever. They were the scaffolding upon which life, consciousness, and meaning could briefly arise. And so, as the galaxies fade into the endless dark, they leave behind their legacy the atoms of every living thing, the light of every star that ever burned, and the memories carried within the beings that once looked up at the night sky and tried to understand. The galaxies will die, but their story will remain written in the elements of the universe, in the space between the stars, and in the echo of light that continues to travel long after its source is gone. The universe is entering its twilight, but twilight is not the end. It is a passage, a moment of quiet before what comes next. For even as galaxies fade and the cosmos grows cold, something new is waiting to emerge, written in the fabric of space itself. The universe, once blazing with the light of countless stars, is now entering its final and most mysterious era, the Age of Darkness. Billions upon billions of years have passed since the Big Bang, and the cosmos has grown vast, cold, and lonely. The galaxies that once filled the night sky have faded into invisibility. The light that once burned so brightly has stretched into longer and longer wavelengths, disappearing into the blackness of eternity. This is the slow death of the universe, not in fire, but in silence. It begins with the fading of the last stars. Red dwarfs, the longest living of all, have burned for trillions of years, slowly converting hydrogen into helium. Their light is faint, barely visible even to nearby worlds, but it endures far longer than any other. One by one, even these quiet suns exhaust their fuel. Their glow dims, their warmth fades, and they become cold, dark remnants, black dwarfs, scattered like ashes across the infinite void. As the last stars die, no new ones are born. The galaxies have long since consumed or lost the gas needed for star formation. The night sky, once alive with light, becomes empty. Only black holes, neutron stars, white dwarfs, and planets remain the leftovers of a once vibrant universe. Black holes, silent and eternal, dominate this new cosmic landscape. They drift through the darkness, invisible except for the way they bend light and space around them. Some roam alone, others lie at the centers of the dead galaxies that once surrounded them. They feed occasionally, consuming the remnants of dying stars or the stray debris of ancient systems. But even these titans cannot last forever. Slowly, over unimaginable spans of time, they begin to lose mass through a process called Hawking radiation, the faint release of energy predicted by quantum physics. It is an incredibly slow evaporation, taking far longer than the current age of the universe. But it ensures that not even black holes are truly immortal. As they evaporate, they release their final bursts of energy, brief flashes in the dark before fading into nothing. One by one, even the black holes disappear. This stage of the universe's decline is known as the heat death. By now, the expansion of space has stretched everything apart to incomprehensible distances. Galaxies that once clustered together are now separated by billions of light-years of emptiness. The cosmic microwave background, the faint echo of the Big Bang, has cooled to near absolute zero. Energy is evenly distributed everywhere, and no work, no motion, no life can exist. Time itself seems to lose meaning in this vast stillness. The universe becomes a sea of dead particles, electrons, protons, and photons, drifting endlessly, never interacting. Yet, even this is not truly the end. For while the universe appears static and frozen, The quantum world continues to hum beneath the surface. Particles flicker in and out of existence, virtual energies ripple through the vacuum, and deep in the darkness, possibilities still exist. Physicists have proposed several theories for what might happen next. In one version, known as the Big Freeze, the universe simply continues to expand forever, becoming colder and emptier until even the faintest particle decays. In this scenario, eternity stretches on, infinite time, with no events, no stars, no observers. Another possibility is the Big Crunch. In this version, the expansion of the universe eventually slows, stops, and reverses. All matter, energy, and light collapse inward again, drawn by gravity, ending in a final singularity, a mirror image of the Big Bang. From that collapse, a new universe might be born, beginning the cycle anew. And then there is the Big Rip. If dark energy, the mysterious force accelerating the expansion of space, grows stronger over time, it could tear the universe apart. First, galaxies would be pulled away from each other. Then, stars and planets would be ripped apart. Eventually, even atoms would be torn from within, leaving only pure energy scattered across an ever-expanding void. Whatever the final fate, one truth remains. Everything that exists will eventually transform. Nothing truly disappears. It merely changes form. From light to dust, from dust to energy, from energy to silence. And perhaps that silence, too, will one day give birth to something new. Some scientists speculate that the death of one universe might lead to the birth of another, that within the final collapse or fluctuation of quantum energy, a new Big Bang could emerge, starting time and space all over again. In this view, universes may come and go endlessly, each one giving rise to the next in an infinite cycle of creation and rebirth. If that is true, then our universe is not dying, but transforming, not ending, but resetting in the far future, long after the last black hole has evaporated, long after the last particle has decayed. Quantum fluctuations might give rise to a new burst of energy, a new expansion, a new Big Bang. Space and time would begin again, with new laws of physics, new galaxies, and perhaps even new forms of life. And maybe, in that newborn universe, intelligent beings will one day look up at their own night sky and wonder how it all began, unaware that they are looking into a cycle that has repeated endlessly forever. But even if no new universe follows, the story of this one remains eternal, written in the elements, in the light, and in the consciousness that once arose from it. For every moment of joy, every act of discovery, every heartbeat that ever existed was part of the universe's grand unfolding. The death of the universe is not a tragedy, but a transformation. It is the quiet return of everything to the same stillness from which it once came. And though the stars will fade and the galaxies will vanish, the memory of their light carried in the atoms that once formed life, in the energy that once filled the skies, will never truly be lost. For in the endless silence that follows, the essence of existence remains, the echo of creation itself, forever expanding into eternity. The universe has grown silent. Time has stretched beyond reckoning. Not billions, not trillions, but countless trillions of years. All stars have faded, all galaxies have dissolved, and even black holes have vanished. The great story that began with the Big Bang seems to have reached its final chapter. Space is vast, empty, and cold, filled only with the faint hum of particles drifting endlessly in the dark. It seems like the end of everything. Yet perhaps, hidden within that stillness, lies the beginning of something new. In this final era, The universe exists in what physicists call the dark epoch. Temperatures hover just above absolute zero, and matter has decayed into its smallest components: protons, electrons, photons, and neutrinos. These remnants wander aimlessly through an infinite void. With no stars to shine, no heat to flow, and no structure to form, the universe appears frozen in eternal quiet. And yet, even in this emptiness, the laws of physics still whisper their secrets. Quantum mechanics, the strange and subtle language of the microscopic world, does not allow complete stillness. Space itself is alive with fluctuations, tiny, momentary surges of energy that appear and vanish in the blink of an eye. They are called quantum fluctuations, and they could hold the key to the universe's next act. Perhaps, within one of these fluctuations, energy could condense just enough to trigger a new explosion, a new Big Bang. Space and time would burst into being again, giving birth to another universe. Its physics might be different. New laws, new constants, new matter, but the pattern would repeat. This is the idea of cosmic rebirth, or the cyclic universe. In this view, the end of one universe is never truly the end. It is the seed of another. Just as a forest fire clears the land for new growth, the death of one cosmos creates the conditions for another to emerge. Creation and destruction become two halves of an eternal cycle, endless, boundless, and beautiful. Other theories suggest something even grander, that our universe is not alone, but one of many, an infinite multiverse. Each universe, born from its own quantum event, expands in its own direction, with its own version of time and physics. Some universes may be lifeless and brief. Others may give rise to stars, galaxies, and perhaps beings like us. In this endless cosmic sea, every possibility exists somewhere. If this is true, then the end of our universe is simply a transition, a quiet moment between one act and the next in an infinite performance. Somewhere beyond our perception, new universes may already be blooming, their own stars igniting, their own forms of life awakening. And even if no new universe arises, even if this truly is the end, then it is still a magnificent one. For the universe has fulfilled its purpose to exist, to create, to become aware of itself. From nothing came everything. From chaos came order. From matter came life, and from life came consciousness. For a brief moment in cosmic time, the universe looked back upon itself and understood. We are that moment. Every human thought, every discovery, every glance at the night sky, all of it is the universe reflecting on its own existence. When we ask, why are we here? We are the question and the answer both. As the final particles drift apart, the story of everything that ever was, the galaxies, the stars, the planets, the beings who wondered about them, remains etched into the very structure of space-time. Nothing truly disappears, it merely transforms. Energy becomes space, space becomes silence, and silence holds the memory of everything. In this final silence, there is peace. No suffering, no conflict, no fear, only stillness. And within that stillness lies potential, waiting for the next great unfolding. Perhaps one day, far beyond even the concept of time, that potential will awaken again. Another spark, another burst of energy, another dawn of light. Perhaps in that new universe, beings will evolve, look at their own stars, and wonder, as we once did, where it all began. And maybe, just maybe, somewhere deep in the fabric of their cosmos, a faint echo of ours will remain not as light, not as matter, but as memory. A trace of the universe that came before, lingering like a whisper from a dream, too ancient to recall. The universe, then, is not a single story, but an eternal symphony. Each universe is a note, each era a rhythm, each conscious being a fleeting melody. Together, they form an endless song, the sound of existence itself. We often think of the end as something final, but in truth, there are no true endings in the cosmos, only transformations. The Big Bang was not a beginning, and the heat death will not be an end. They are both transitions, part of a continuum beyond comprehension. If time is infinite, then so too is creation. The cosmos will rise and fall, expand and collapse, again and again, forever. And each time, it may give birth to new forms of beauty, new stars, new minds, perhaps even ones that remember faint echoes of universes long gone. And so, in the deepest darkness, the universe is reborn again and again. It all began with a burst of light, and it ends with a whisper not of sorrow, but of promise. For the story of the universe is not about permanence, but about transformation. It is about energy, finding new forms, matter, seeking meaning, and consciousness emerging from dust. The universe began in mystery, and it will end in mystery. And in between, there was light, the light that became life, the life that became awareness, and the awareness that looked up at the stars and realized that it was part of them. The end, then, is not the final word. It is simply the pause before the next verse in an infinite poem written by existence itself. From nothing to everything, and back to nothing, and in that nothing, everything again. The story continues forever.